Welcome back. This is the third lesson recording for IM2, February 11th, 2021. I am going to go through the factoring process again using the guess and check. Okay, so when you have 6x squared plus 35x plus 25, again, you're going to start by putting the template. So the only way I can get 6x squared is either 6x and an x or 2x and 3x. I'm going to try 2x and 6x, 2x and 3x first. Okay, and then if it doesn't work, then I'm going to go to 6x and an x. Now I'm looking for factors of 25. What are the factors of 25? That's only 1 and 25 and 5 and 5, right? So if I have 5 and 5 here, is it possible to get 35? If I put 5 and 5 here, and I know that they are both going to be positive because the sum is going to be positive. That's going to be 5 times 3 is 15. 15 plus 2 times 5 is 10. That's going to be 25. That's close, but that's not going to work. Okay? And then I could try, alright, so that didn't work. I could try 1 and 25. Would that work? 1 and 25. 25 times 2 is going to be 50. 50 plus 3x, that's going to be way too big. And even if I swapped it the other way, even if I put 25 here and the 1 here, that's going to be way too big. So I know that I have to go to 6x and x. Okay, now I'm going to try 5 and 5 here to begin with. That's 5x is 5x times 6 times 5 is 30x. So 5x plus 30x is indeed 35x. So I found my numbers. So that's going to be 6x plus 5 and x plus 5. Now that I've found my factors, I just set each of the factor to 0. So that becomes 6x plus 5 is equal to 0, or x plus 5 is equal to 0. So then subtract 5 from both sides, so that becomes 6x is equal to negative 5, or bring 5 to the other side by taking the negative of it. And then you divide both sides by 6, and you get x is equal to negative 5 over 6. That's one of my solution, and the other solution is bringing 5 to the other side by taking the negative of it. So x is equal to negative 5. So that's my two solutions. Okay, number 15. Okay, Malik is finding solution for the equation x plus 1 multiplied by x minus 1 is equal to 6, and he found the solution to be x is equal to 5 and x is equal to 7. His work is shown on the left. Do you agree or disagree with this conclusion? Well, what did he set each of these to? Before it was equal to 0, and we set each of the factors to be equal to 0. Are we allowed to do this? X plus 1 is equal to 6 and x minus 1 is equal to 6. Are we allowed to do that? No, we're not, because this 6 is not a 0. Okay, 0 is a very special number. Because if something is equal to 0, then when you're multiplying two things and equal to 0, I know that one or both has to be equal to 0. However, if something is equal to 6, there are infinite numbers of ways that two things could multiply to 6. For example, it could be 2 and 3, or it could be 3 and 2, or it could be negative 2 and 3 and negative 3, or it could be something like half and 12, or it could be even, I don't know, it could be a quarter and 24, and so on. There are infinite numbers, and there are positive and negative versions of it that will multiply to 6. So we cannot use this. You need to always set it to 0. So I would say I would disagree. And you have to explain your reason. Keen is also practicing her skill solving quadratic equation, and the equation she's trying to solve is 2x plus 4 in parentheses plus x minus 4 is equal to 0. Her work is shown on the left. Do you agree or disagree with her work? What is the difference? We have this plus sign right there. Okay, that means this parenthesis is not multiplying to the other second parenthesis to give 0. What this is actually is just same as x plus 1 plus x minus 4. Because when you are adding and subtracting, you can get rid of the parentheses like that. Okay, so that becomes 2x, combining like them, 1 minus 4 is negative 3 is equal to 0. So the solution is you bring negative 3 to the other side by taking a positive of it. So 3 is equal to 2x, divide both sides by 2, and you get x is 3 over 2. Okay, the solution is just a one variable equation. Okay, so it's 3 over 2. So this should be a disagree. And you need to explain your reasoning. Okay, so then let's get back to our slides, and now let's bring up a notch in solving quadratic equations. What if you have an equation like this? How do I solve this? That looks complicated. What do I need to do? Well, remember we want to make it equal to 0 so that we can use 0. Okay, so how can I change this so that I have some quadratic equation on the left hand side? So I want to have some sort of quadratic expression that is equal to 0. I wanted to set it to 0. That's my goal, so that I can use 0 product property. Okay, so how do I do that? Well, I see the x squared terms on both sides, so I need to subtract one of them. Okay, because I want to bring this over to the other side. And how do I do that? This is plus 4x squared, so I subtract 4x squared from both sides, and that leaves me with x squared plus 7x on the left hand side is equal to 4x plus 10. Again, I want to bring all of this to the other side. Okay, I want to bring it to the other side, so I can subtract 4x from both sides. That leaves me with x squared plus 3x is equal to 10. And then I also want to get rid of this 10 by subtracting 10 from the other side, both sides, and that leaves me with x squared plus 3x minus 10 is equal to 10 minus 10 is 0. Okay, so I have just converted this complicated equation into a form that I can easily factor. How do I do that? So again, this is my easy factoring. I put my factors x and x here. I'm looking for two numbers that multiply to negative 10 that add to positive 3. So that's going to be 5, positive 5, and negative 2. Because 5 minus 2 is positive 3. 5 times negative 2 is negative 10. So then from here I know that x plus 5 is equal to 0, or x minus 2 is equal to 0. So x is equal to negative 5, or x is equal to positive 2. So I'd like to take the notes here. Solving quadratic equations using zero product property. If they are not set to equal to 0, if you have variables on either side or the numbers on either side, whatever the case, you need to set it to 0. So how do I do that? I need to bring all the variables and all the numbers to the other side. So if I have x squared minus 5x is equal to negative 4, I just simply get rid of this negative 4 by adding 4 to both sides, and this becomes x squared minus 5x plus 4 is equal to 0. Then you factor the left hand side, and then you set each of the factors to be 0, and then you solve for x, and you can always verify your solution to work by substituting it back into my original equation. Okay, my original, not the transformed one, but the original equation, and see, does it hold true? And it should hold true if that is the correct solution. So with that, you are going to continue with the rest of the decimals, and you're going to be working on card number 17 all the way to the end. So for card number 17, what operation is applied to rewrite 3x squared plus 4x is equal to 2 as 3x squared plus 4x minus 2? What do I need to do to both sides? I am going to, how can I get rid of this plus 2 on that side so that it's going to become 0? 2 becomes 0, I need to subtract 2. So I am subtracting 2 from both sides of the equal sign equation. Alright, then what about, this is like what you did before, but you're filling in the steps. Okay, so it should be pretty straightforward. It gives you all the descriptions, and then finally factoring, and then setting both factors to be 0, and then solving both equations and finding the solution. So 18, 19, and 20, and 21. Okay, so it's basically following all the steps of the previous steps. Okay, just setting it to 0. So please try to do it yourself, and then finally you are going to do a quick reflection on how confident do you feel about factoring and solving quadratic equations from today's lesson, and you're going to adjust that. And with that, I want to leave you with a methogram. It's a fundamental methogram. This is a fractal, where it is a picture of a repeated pattern over and over again at a different scale, and how this complex shape can be formed by a simple repetition. So let me show you the methogram, because it's Valentine's coming up and it's pretty cool math stuff. So if you want to impress your Valentine, you can impress her with some cool shapes like this or this. Okay, and let me show you that this is all math. Okay, so this is, look at that, you could change that flower into a heart. And the behind the scenes, how did we do that? It is all math equations, believe it or not. And likewise, I can create a fractal. This is Sierpinski's triangle. So you can create one heart, and then from there, each of the 3 corners I can create half size, surrounded with half size of each heart, and then do that again and continue to do that, and you end up with a fractal. Here you go. And this is pretty cute too. Voila. And we're going to close by entering in the table of content in your notebook what we covered today: solving quadratic equations using zero product property. Thank you for listening.